Right. Welcome back to our page, AfriEdge. Kindly subscribe, share, comment. Your additions are welcome. Your inputs are welcome. So in this question, we are going to be doing a question on probability, which is a question from November 2018, grade 11, question 9. So you are given that on a flight, passengers could choose between a vegetarian snake and a chicken snake. The snakes selected by the passengers were recorded. The results are shown in the table below. Then, this is the table that we are given here. Then, was the choice of snake on this flight independent of gender? Motivate your answer. So, if for any independent events, if you are having event A and B and they are independent, it means the probability of A and B is equal to probability of A multiplied by probability of A, times probability of B. So in this case, it was possible that gender you can consider male, then snake you consider vegetarian. So are those two events independent? You just go and say, let's do the calculate by calculating considering M to be male. So it means the probability of male intersection vegetarian must be equal to probability of male multiplied by probability of vegetarian. So if we are to check what is the probability of male and vegetarian, we go to our table. We go to our table to check the probability of male and vegetarian. If we go to our table, we check where male and vegetarian are intersecting. We go where male and vegetarian are intersecting. This is where they are intersecting. So they are 12. So we go there, 12. So male and vegetarian, it's 12 over the total number of people who are there. It's 150. This must be equal to probability of males. How many males are there? We go to males. We have got 67 males out of a total of 150 multiplied by how many vegetarians were there is 32 over 150. Then compare the two. Are they really equal? So it means we just have to simplify. This one is over 150, not over 15. It's over 150. So we are going to say 67 over 150 multiplied by 67 over 150 multiplied by 32 over 150. It's giving 0.09. Okay, if you check here, it's giving 0.10. When you round off to two decimal places, 0.10. And if you check 12 over 150, on the other hand, it's giving 0.08. So since the left-hand side is not equal to the right-hand side, we can conclude that gender and snake and the choice of snake are not independent. Are not independent events. You can use anyhow. It was possible that you can use male and chicken. If we are to use male and chicken, it means we were going to say probability of male intersection the probability of chicken must be equal to probability of male multiplied by the probability of chicken. Then what's our male there? Probability male intersection chicken. You just go to our table where we have male and chicken. You would realize here are they. It's 55 over the total number, which is 150. This must be equal to probability of male. The total males are 67 over 150 multiplied by those for chicken. Chicken is 118 over 150. Then simplify. There we are going to have 67 over 150 multiplied by 118 over 150. If we are to check, we are getting around 0.35. Then the other side, 55 over 150, we are getting around 0.37. If we are to check, the left-hand side is not equal to the right-hand side. So we can conclude that gender and snake are not independent. It was possible that you can even do the calculation using female and any, but just know that if we were to use female, again, it was going to be, for example, probability of female. You choose any snake, female intersection, vegetarian. If they are independent events, this must be equal to probability of female multiplied by the probability of vegetarian. So doing that, probability you go female and vegetarian where they're intersecting, we have 20 over a total number of people, 150, where they are intersecting, that's here, where there are 20 divided by the total number of people. This must be equal to female. How many females are there in total? There are 83 over a total number of, which is 150, multiplied by how many vegetarians? There are 32 over 150. So what are we going to get? It's going to be 83 over 150 multiplied by 32 over 150 is giving us 0.12. Then the other side is 20 over 150. Which is given 0.13. So since the left-hand side and the right-hand side are not equal, still we are going to conclude that these are not independent events. Then let's go to 9.2. 9.2, we are told that for any two events A and B, it is given that probability of A and B is equal to 0.12 and probability of A or B is equal to 0.83. And we are also given that probability of B is equal to 4 times probability of A. Then the first part is saying, the first part of the question, which is 9.2.1, 9.2.1 is saying, are events A and B mutually exclusive? Justify. We know if we have two events A and B, if They are mutually exclusive. For mutually exclusive events, we have to know that probability of A intersection B must be equal to 0 for mutually exclusive events. But in this case, we are told that probability of A and B is equal to 0.2. So are the events mutually exclusive? So it therefore means that events are not mutually exclusive. Events are not mutually exclusive. What's the reason? Because the probability of A intersection B, which is probability of A and B, is not equal to 0, or you provide the reason by giving the actual probability that you are given. So it was possible that you can just provide the reason as because probability of A intersection B is equal to 0.12. So we can conclude that these two events are not mutually exclusive. For mutually exclusive, the probability of A and B, A intersection B, must always be equal to 0. Then the next question is saying calculate the probability of B. Calculate the probability of B. So from what we are given there, number 1, we know, so we are going to 9.2.1. We know that probability of A or B, which is A union B, must be equal to probability of A plus probability of B minus the probability of A and B. If we are to do substitutions, probability of A or B, we are given as 0.83. Then probability of A, we do not know it. Probability of B, we do not know it. Minus probability of A and B, we are given it as 0.12. So using this, we can therefore conclude that probability of A plus the probability of B must be equal to 0.83 plus 0.12, which gives 0.95. We now have 0.95 for that, but we are also given, so this is our equation number 1. But there is something that we are also told. We are told that probability of B is equal to 4 times probability of A. Sorry, 4 times probability of A, 4 times probability of A. That's 4 multiplied by the probability of A Then the question is saying calculate the probability of B. calculate the probability of B. So it means becomes our equation 2. So we want the probability of B. So we can use the equation 1 to make probability of A the subject of the formula. So it means using this equation, we can make probability of A is equal to 0.95 minus the probability of B. So we substitute that in our equation 2. So it means the probability of B will be equal to 4 multiplied by where there is A is going to be 0.95 minus the probability of B. So 0.95 multiplied by 4. It's going to give us 3.8. So it means probability of B here must be equal to 3.8 minus 4 times the probability of B. Then if we add 4, the probability of B, to the other side, we are left with 5 multiplied by the probability of B being equal to 3.8. Then we divide both sides by 5. So it means the probability of B will be equal to 3.8 divided by 5, which is equal to 0.76. This is our probability of B. Then we are done. Then the last part is saying calculate probability of not A. So to get probability of not A, we first need to get probability of A. So since we have probability of B, we have to know that using the statement that we are given that probability of B is equal to 4 times the probability of A. So the probability of B, we found it to be 0.76. This must be equal to 4 multiplied by the probability of A. So to get the probability of A, we are going to divide both sides by 4. So our probability of A will be equal to 0.76 divided by 4. Which is giving us 0.19. This is the probability of A. Then we have to know that probability of not A must be equal to 1 minus probability of A. So it means probability of not A must be equal to 1 minus 0.19, which is going to be equal to 0. It's 1 minus 0.19, which is equal to 0.81. Thank you.